I welcome you all for this video lecture series on operating systems. Today our topic is dynamic storage allocation. Before that I introduce myself. I'm Shankar, working as assistant professor in the Department of Computer Science and Engineering, R&D Engineering College, Chennai. Let's go for the lecture. Dynamic storage allocation problem concerns how to satisfy a request of size n from a list of free holds. It means that we have a list of free holds, free area. We need to allocate a file, right? So how we can satisfy to allocate free to allocate size in the file through dynamic storage allocation. That is actually our aim. For this, we have many solutions. So here we have discussed, we are going to discuss first fit, best fit, and worst fit strategies are the ones most commonly used to select free holes from the set of available holes. Holes in the sense free areas. Among this, let us discuss first fit. The first fit allocate the first hole is big enough. Searching can start either at the beginning of the set of holes or at the location where the previous first fit search ended. Right? It's just one of the important ones, right? Because you just noted down. Searching can start either at the beginning of the set of holes or at the location where the previous first fit searches ended. This we need to remember always. We can stop searching as soon as we find a free hole that is large enough. I'll tell you one simple example just for an imagination, right? So suppose if you have totally 500 KB, right? So here I have how many partition? Let's say, right? Some partitions I have. So how many partitions I have? 1, 2, 3, 4, 5. Just imagine, right? So this is maybe 150 KB hole. This is maybe 150, and this is 100. So totally we have 250, and this may be 75, and this may be 75. So total how many? 75, 75, 150, 150 plus 100, 250, 300, 400 is allocated plus 100. Right? So 250, 250, 500 KB. These are all in KB, right? Okay. So initially, in this case, I'm telling a small example. I want to allocate 75 KB now, right? I want to allocate 75 KB now. You just see the point here. The searching can start either at the beginning of the set of holes or at the location where the previous fit search ended. I'm taking the first one, right? Always it search the beginning. If it's beginning in the sense, beginning itself, how much free space we have? 150. How much we required? 75. So what happened here? 75 is allocated. If 75 is allocated, the remaining 75 is free. Is it correct? 75 is allocated, remaining 75 is free. Okay, next what I should do is I want to allocate 100. In this case, first initially it's search here. We have only 75 free space. The rest is 100. So here 100 is allocated. If you want to allocate 80, initially there is no space. And this space is already allocated. 75 not enough. 75 not enough. From this 100, 80 is allocated. I hope you understood how the memory is allocated. It searched one by one from the beginning or previously where it is ended. I'm taking the beginning, right? For every allocation, it searched from the beginning. It searched the free space where the free space is there, sufficient free spaces. Even though the upcoming we have free space, if it is large or small, that's not a matter. Free space, right? If the first hole is free, it allocates, right? That is the first fit method. The next one is best fit method. In the best fit method, it allocates smallest hole that is big enough. So in this case, we must search the entire list unless the list is ordered by size. This strategy produces the smallest leftover hole. We can take the same example. You just consider, right? What I said initially, it is allocated for 150, and next, I think 100, right? I think 100. Next, 75, 75, 75, 75. Again, we have 100. You just take the same example. Just same example. Initially, what we have assigned 75. But here, it's not search from the first hole. What I said, allocate the smallest hole. It is the beginner, right? So what is the smallest among this? 75. So two are same in size. So initially we will allocate the first 75 initially. Okay. Then what is the next one? We are allocating 100. What is the smallest one? This 75 is allocated. So 75 is smallest, but it is not enough. What's the next smallest? 100. So here we are allocating this 100 is allocated. And what's the next one? 80. What's the smallest one? 75. 75 is not enough for 80. Right? So the next smallest is 100. So this 100 is allocated. Only 80 is allocated. The remaining is free. You just consider, take a total of free space here. Here 75 is there. 75 plus 75 plus 75. 225. And here 100 is allocated. No, 20. 225. So 245 is remaining, I think. Just take a note. Here 75 is free. Here 75, 75 is 3. So 225. Here 80 allocated plus 20. So 245 is free space. So the same example, you consider the best fit. How many is free? 150 plus 75. 150 plus 75, 225. Again, here is also 245. Sometimes it's vary based on the example, right? Yes. And next, worst fit. In worst fit method, it allocates the largest hole. Again, we must search the entire list unless it is stored by the size. This strategy produces the largest leftover hole, which may be more useful than the smaller leftover hole from the best fit approach. Let us see the same example. How we have partitioned 5 partitions, right? The first partition is 150, I think. I think it is 150. And next two are 75. And next two are 75. Right? Oh, 100 and 75. Right? So this is 100. And this is 75. Right? 150, 100, 75, 75. Again 100. Let us consider the same example. Right? So initially how much we require? We need to allocate for 75. So as of this example, we have to allocate the largest hole. What is the largest hole? 150. Among 150, we are allocating 75. Among 150, we are allocating 75. So remaining 75 is free here. And next one is 100. We should allocate 100. So for 100, what is the largest one among this? Initially 75 allocated. So 75, 75. The next largest is 100. 200s are there. I have used 100 here. Right? First I have taken. Right? And next what we should allocate? 80. For 80 I'm searching for the next highest. The next highest is 100. From this 100 I'm allocating 80. The remaining is 20. So again 75, 75, 75, 225, 245. Here all are giving same same free memory space. But in some other example it will not be same because here some for the allocation some requires first fit may be good, some require, some may be best fit maybe gives very less number of free space like that, right? That we need to concentrate. Based on the example, it's varies. As per our example, what I have taken here, it gives the same solution. So in this case, all are best strategy for allocating memory, kernel memory. I thank you all for this watching this video lecture series. I thank you once again.